Welcome to the second section of the course. In this section, we will shift our focus to behavior-driven development and its core principles, the most important of them being the red-green refactor principle. Red means a failed test, so we begin by writing the tests first, with no implementation. This normally means that the tests will fail, and thus the color red that usually accompanies a failed test. Then we have green, which you guessed it, means successful tests. So right after describing the behavior we want out of our system under test, we go ahead and implement the code. We don't have to write the best code ever. It does not have to adhere to the best principles or be clean and maintainable yet. We just aim to pass the tests no matter what. This is what green means. Make the tests pass as fast as possible. After that, we can go back to the code and refactor it to be the best possible code we can write. After refactoring, we run the tests again. If the tests succeed, it means that we have written optimal code that matches the desired behavior. Let's see how we can use that BDD approach in the following example while building a library that resizes an image to half of its original size. In order to edit our images and reduce their sizes, their dimensions, and cut their width and height in half, we are going to use GIMP, which is an image manipulation library for Node.js. I'm going to do a quick npm install for that library, and then, since we are following a behavior-driven approach, we are going to create the test first, and after we describe exactly what the behavior we want out of our system under test, we are going to move on and create the actual implementation. So as you can see, GIMP has finished being installed, so we can go on. I'm going to clear the terminal window. First, remember, we are going with a behavior-driven approach. We write a test first. So I'm going to just place something like a placeholder function just to define the interfaces. How our resizer library does look like, and then we are going to go ahead and create the spec file first, and this is what we're actually going to implement throughout most of this video. So we're going to focus on this file, on the resizer.test.js file. As you can see, I'm including chai. I'm going to use Mocha and chai for the test, but you can use your favorite test suite if you like. There aren't many differences in the actual approach. You can write behavior-driven tests with Jasmine. You can do it with Mocha and chai like I'm doing right now. There are a lot of choices out there, a lot of tools you can choose from. And we're also going to need the fs library. And I'm also going to include the promissify function from the Node.js utilities library to make everything asynchronous and avoid having to use callbacks. Next, we are going to describe the resizer and everything we place within the following block. This block right here will describe scenarios, use cases for our library. Let's begin with the errors first. A library that deals with images, with image files, should throw an error when the given path is invalid. Another type of error that could be thrown has to do with the output path. I mean, we also need to use a name for the output file. What if the one passed is not valid or it's not given at all? I mean, it's either null or not supplied. Generally, something that is falsy in JavaScript. This is what we should catch in that case. And then what if the actual file does not exist? Maybe the path that we provide is valid. It's a valid string with length greater than 0, but the file itself doesn't exist. The path cannot be resolved. Again, we have another use case that results in an error, and like we said in the previous section, it's always a nice practice to include the error test cases first, followed by the actual functionality with the most successful cases. Finally, we have the successful case, in which case we want the image to have reduced file size and half of its dimensions. So let's move on to the first test, in which we call the resizer function without passing anything. So the path is invalid, we expect an error to be thrown, and we expect the message to equal something. Now, this is why writing your tests first can actually act like writing a spec file. Also, don't forget to call the failed test if, for some reason, an error is not thrown after calling resizer with an empty file name. I'm going to copy this whole section just to not repeat ourselves, not having to write the try-catch block all over again. And this time I'm going to provide a valid file name, so samfile.png, followed by file path is an invalid output path. And let's move on to the third error now. Let's copy this whole block, paste it here. And now we need to provide an image that is valid, but doesn't exist. I mean, the path is valid. Whatever.png is valid, but we don't have such an image in our project's directory. So we expect an error to be thrown with image does not exist. Moving on to the successful case, now this is where we should define what we expect out of our resizer. Now, what do we expect? We expect the image to be resized to half of its original size. Now, this is the HTML5 logo. We're going to go with this one. We're going to use it as a file for our test case. So I'm going to include its path. It's HTML5 underscore logo.png. And let's say that we want the converted image to be stored in a file called HTML5 logo half.png. So we call the resizer, passing in the source and the output path. And this is where we should use the FS library, the file system library that Node.js provides, to inspect both files and see whether the resizer did its job. Now, if we wanted to check the actual dimensions, we would have to use GIMP, which is not a good idea since the resizer is using GIMP. A little better way of having the same result and making sure that the conversion works and the test passes is to check the size in bytes. So almost always when you cut the image to half of its original dimensions, if you reduce the width and height, then you expect the output to be of less size in megabytes. I ran the tests, they failed because we don't have an actual implementation, so we are in the red step of the red-green refactor of the basic principle that behavior-driven development is all about. So now let's go ahead and actually implement all of the methods that we need in order to pass the tests and move to the green step in the process. So I'm going to include GIMP, the library that we installed a few minutes ago. We need the file system library, and we also need Promisify from the utilities library to make everything asynchronous and work with promises. So we can use async await. So if the source doesn't exist, this is covered by our first test case, we should fail with a message like source is missing. If the output is missing, again, we're going to use the tests as guidelines, as specs, so that we say that the correct error to use at this point is output is missing. Then we check if the file exists. And if it doesn't exist, again, we're going to use the exact same message that we've already written in the spec file, which is image does not exist. Perfect. Now let's use GIMP to read an image from the source. This is an asynchronous operation, so I'm going to use await. GIMP supports promises, so we don't have to use Promisify on it. And then we retrieve the width and height. We want to cut them down to half of the original dimension, so the new width is going to be half of the original width. I'm going to use the ceiling function to make sure that the actual value is an integer. So we round it up to the nearest integer. And now it's time to write the new image. So I'm going to use image.resize with the new width and new height. And now let's write it to an actual file, which is going to be the output. So this path is the output that we provided. And we've already checked that this is a valid path, of course. Let's run the tests. Some of them pass, but one of them fails. Let's see what happened. Callback must be a function. This is what it says. And this is usually the source of this error is a bad usage of the Promesify library most of the time. And yes, this is what this is caused. We need to give the source and output file names to fs, and now everything passes. We have 4 green ticks, which means that our library is working. Now let's refactor it. Let's take all of these checks outside of the function and replace them with this check source method or the check output method. I'm going to use Ctrl+Shift+R on VS Code to refactor the code into a function in the global scope. Same with this, so hit Ctrl+Shift+R, give a name to the function, check if source exists, and the methods are generated at the bottom of the file. You can move them to the top if you like, or you can move the other one at the bottom, depending on what your conventions are. Perhaps you have a linter for that. Depends on the conventions you and your team have established. Now, let's run the tests again, now that our code has been refactored and they pass again, so we're good to go.